How's everyone doing? You're back with Jono for another quick math lesson. Today we're going to look at how to find the area of a triangle. And not just looking at what the actual formula is, but we're going to prove how we get there so you can use this forever. So the first thing we've got to remember is that the area is trying to find out how much space an object takes. And sometimes we can think about this as how many little 1 centimeter square boxes fit inside a shape. So really quickly, if I had something that looked like this, a rectangle that goes up 3 boxes and across 6 boxes, instead of counting all of these up, I know I've got 3 boxes up that happens 6 times in total. So I just have to multiply those two numbers together, which is really 3 multiplied by 6, which is equal to 18. So assuming these are both centimeters, so something like this, 3 centimeters and 6 centimeters. So each box there is a 1 centimeter squared thing. Do just have to make sure you've got that in your answer. If you just say, hey, there's 18 of these things, that's not going to be enough information. You do have to say there are 18 centimeter squared boxes within that thing, which just goes to 18 centimeters squared. Remembering that squared always means area. Unfortunately for us, triangles are a little bit tricky. If you have a look at this triangle here, you could try to count the boxes up, but it gets really hard with that diagonal line in there. Like, do I count this little bit inside as exactly half of that box? It kind of looks like half of the box, but maybe not exactly. This little bit's even harder. There's some part of that box within that diagonal line, but not much. I can't just guess how many there are. So it becomes much harder. I just can't count up these boxes. So in order to actually get these correct and find out where the formula comes from, we've got to ask ourselves, what actually is a triangle? We know that a triangle has got 3 sides, happy days. We probably also know that the triangle has 180 degrees of angles inside it, but these two things won't actually help us with this formula. What we're going to do is find out a visual proof where we see, oh yeah, that's obviously what a triangle is. So if I had a look at this rectangle here, what I could do is find the area out of that and find the area of the rectangle pretty easily, just by multiplying length and base. But if I put through a perfectly straight diagonal line from one corner to the other, something like this, dotted all the way up there, you can see incredibly quickly that I've turned one rectangle into 2 triangles, if I could draw that line straight. But what that means is that I have 2 perfectly identical triangles that have come out of one rectangle. So that means that a triangle, by definition, is just half of a rectangle. And this makes finding out what the area of a triangle super easy. Instead of counting up these half boxes or whatever like that, all we've got to do is do our normal rectangle formula, which is super easy, length times base, and then multiply it by a half, or even divide it by 2, whichever makes more sense to you. So that means the formula for finding one of these is just a half multiplied by the length of the base, so multiplied by base, multiplied by how high up it goes. And we're going to use the letter H for this. So that means the formula is a half times base times height. How you're going to see it written though is without those multiplication signs, just because we don't like those in algebra. So we're going to have a half BH, and that is our formula for the area of a triangle. So that means if I've got a question like this, I've got to find the area of this triangle. It's got a base of 5 and it goes up 4. So all I've got to do here is use my formula. If this was a normal rectangle, I would be able to count those up and find that there are 20 boxes in there, 4 times 5. But what I've got to do here, instead of doing that, I can just say, oh, it's a half multiplied by 4 centimeters multiplied by 5 centimeters. And then you just have to work this out. A half times 4 is 2, and then 2 times 5 is 10. That's one way you could do it. You could also go 4 times 5 is 20, then multiplied by a half takes it down to 10. Either way is going to be totally fine. Multiplication can happen in any order. But this answer is just 10 centimeters squared, and that's all we've got to do. So that works all well and good for a right-angled triangle that we saw there. It was obviously half of a rectangle. But what about non-right angled triangles? So looking at this one, it's a little bit harder to see that this is exactly half of a rectangle, but I'll show you that it actually is. So for this one, we've got to have the base, right? That goes all the way along down the bottom, and we still have to have the height. The height of this is like, how tall is that pyramid? We're not taking the side length. We just want to know physically what's the top point? So the height goes down this line here, and that's our h there. So while it might be a little bit harder to see that this is exactly half of a rectangle, we could break it up into two rectangles and see that it's pretty cruisy. So if this is a right angle here and this is a right angle here, if I drew in two imaginary boxes around this, we'll see that these are half exactly. So this up here is exactly the same as this side. They're just flipped over each other. So the bit in the black, the thing that I had there to start off, is exactly half of that rectangle. And then again, if I went all the way over here and straight back down, this side that I've drawn in is exactly half of the side that it's been mirroring. So that means on both sides we had two rectangles and both triangles were half of the rectangle. So all we need to know is that that holds up for the entire thing. So even though this triangle wasn't right angled to start with, once we put that imaginary height line in, we could make two little rectangles and see that it's exactly the same thing. There are heaps of really good proofs of this on the internet in other places, and I really highly recommend having a look at them just to prove that you know that this always holds up. So when we leave this lesson, the only thing you need to be able to do is find the area of a rectangle, base times height, and then multiply that by a half. If you can do that every time, you're going to get all of these triangle questions right every single time. Thanks so much for watching, guys, and I'll see you later.